Hi, dear students. Now we reach to the last part from lesson 1, chapter 2, the light. This part start with Snell's law. It start with Snell's law. Snell's law studied the relation between the relative refractive index and the angle of incidence and the angle of refraction. Here we know that n12 equal sine phi over sine theta, and n12 equal n2 over n1, of course. So we can say that sine phi over sine theta equal n2 over n1. Here, if we made here crisscross, you will find that n1 sine phi it equal n2 sine theta. n1 sine phi equal n2 sine theta. This is the relationship here. This means that the absolute refractive index for medium of incidence times sine the angle of incidence equal the absolute refractive index for medium of refraction times sine the angle of refraction. This is called Snell's law, and you can use this law to calculate which of these absolute refractive index in medium 1 or medium 2 or angle of incidence and angle of refraction. It's a very important law. It isn't very simple as you see here. Here note, of course, n12 it equal n2 over n1 and n21 equal n1 over n2, both reciprocal to each other. So n12 equal 1 over n from 2 to 1. Here the third process which make the light is considered a wave, the light interference. What's the meaning of light interference? It's a phenomenon of light waves produced from two coherent sources. It's a phenomenon of light waves. These two waves produced from two coherent sources. What is the meaning of coherent sources? Coherent sources means these two sources have the same phase and the same frequency. Have the same phase and the same frequency. And the interference between these two waves will produce bright areas and dark areas. These bright areas are called bright fringes, and the dark areas means dark fringes. The bright fringes here is called bright due to it causes reinforcement of light, and here the dark areas here is called the dark fringes due to it causes weakness of light. The scientist which studied this process here, Thomas Young's experiment. On number one, on operating the light source, this light source should be monochromatic source. What is the meaning of monochromatic source? This means it has only one wavelength. First, this light will fall on a screen. This screen has one slit. The aim of this to make the light wave passes from this slit. Slit means open. It has an opening. This opening make the light wave passes through it in the form of cylindrical wave. Cylindrical wave means it has a front wave. This front wave, all the points on the front wave will have the same phase, of course. Due to this source of light is closed source, and the light produced from it will be in all directions, and we need to make the light rays move in one direction. This means it will have the shape of a cylindrical wave. After that, this cylindrical wave will fall on a double slit screen. This double slit screen will be worked as two sources has same frequency and same phase. This means these two slits will be two coherent sources, have the same phase as in front of you. The two waves propagate and reach at the end observation screen. What the interference will happen between the two waves, and this interference may happen between the crest from the first with the crest from the second, and if the crest meet the crest will give to us a bright fringe. If the trough meets the trough, it will give to us a dark fringe. So if the crest meet the crest and the trough meet the trough, this will be called constructive interference. Constructive interference. This means this will happen reinforcement for the light. And the difference between the two waves in phase will be 0 or lambda or 2 lambda or n lambda. This is the difference in phase between the two waves and the constructive interference. But the dark fringe when the crest meet the trough of the second, here the difference in path between the two waves may be half lambda or 3 over 2 lambda or 5 over 2 lambda or n plus half lambda. This is called destructive interference. Here in front of you a very important definition, which is called wavefront. Wavefront, it is the surface of the wave, as we said, which all its points have the same phase, and this surface is perpendicular to the direction of wave propagation. What is the meaning of coherent light sources? Coherent light sources, they are sources that produce wave of the same frequency and phase and amplitude. Of course, you remember this concept. We studied these concepts in the first chapter. Interference fringe, it's the sequence of bright and dark straight parallel regions. From here, what are the factors that affect the distance between two bright fringes or two dark fringes? Young gave these symbols here. Number 1, lambda is the wavelength of the monochromatic light. R, it's the distance between the screen which has one slit and the screen which has two slits and the observation screens, the last two screens. D is the distance between the two slits. So delta y equal lambda r over d. Again, delta y is the distance between two similar fringes, maybe maybe bright or maybe dark. So delta y equal lambda r over d. It's directly with lambda. Lambda is the wavelength of the light. It's directly to r. It's called range. It's the distance between the observation screen and the double slit screen. And delta y inversely with d. D is the distance between the two slits. From here, what's the meaning of this? Is the end of the light interference. Remains for us only one process, which is called light diffraction. This is the light diffraction. What's the meaning of light diffraction? Light diffraction, it's a phenomenon on changing the direction of light waves when they passes through a small aperture, leading to the interference of light waves and the formation of bright and dark fringes. Okay, here this experiment will be made by Airy. Airy will let a source of light, of course it will be monochromatic light. This light has one value of the wavelength and fall on one screen. This screen has only one slit. He found that during the passing of the light ray from this one slit, it will be separated to two rays, and these two rays produced from one source. This means that these two rays are called coherent waves. Two coherent waves have same frequency, same amplitude, and the same phase. So the interference will happen between these two waves, forming two types of fringes, bright and dark fringes. So always the center spot is bright, due to always the interference between the two waves happened in this area is constructive interference. This bright spot is called the Airy disk. So from here we can define Airy disk as this. It's a bright circular spot. It's a bright circular spot formed on the observation screen. When a monochromatic light waves diffract means it changes its direction but without separating surface through a circular aperture. Here the condition of light diffraction. We have here a very important condition to make the light diffract. It's the wavelength of light should be comparable to the dimensions of the aperture. What is the meaning of that? Of course, the light wave which falls on the aperture have a certain value of the wavelength. This certain value of the wavelength should be its value close to the dimensions. The dimension of the aperture means the diameter of this aperture. If this diameter is so wide than the wavelength or so narrow less than the wavelength, it will be a big problem. Why? Due to it will not let the light diffract. So we can't see the bright fringes or the dark fringes on the observation screen of every experiment. This is the condition of light diffraction. Now let us move to this the next point, which is called resolving power. If we have 2 point sources and let it produced from each through a circular aperture, then each source will form separating fringes. Again, if you have 2 sources of light, these 2 sources of light produce 2 separated light waves. If both passed from a circular aperture, of course each one will form its own separated fringes, bright and dark, of course. As the distance between the 2 sources decrease, the fringes get closer to each other, and it will be difficult to identify them or separate them or recognize which one belongs to the first wave and which one belongs to the second wave, because of the diffraction, of course. Number 3, the ability to resolve 2 small objects is inversely proportional, of course, to the aperture diameter and directly proportional to the wavelength. This relation is very important. Here we can answer together these questions to let you train on some important ideas which you may find in your exam. and I want to remind you that exercises is very important. Please take care of exercises. Due to the exercises will make you able to understand the examiner want what from you. So here let us discuss this point together. Write the suitable terminology for each of the following statement. What is the meaning of that? I want from you to write only one word. Convert these sentences to only one word. Number one, it's the included angle between reflected light ray and the normal line at the point of incidence on reflecting surface. Its angle and included between reflected ray and normal. What is this angle? Try to think. What is this angle? It's angle between normal and the angle of light of reflection. This is called, yes, you're right, it's angle of reflection. It's angle of reflection. Number two, try to read with me. The ability of the medium to refract light ray when they pass through it. Again, the ability of the medium to refract light rays when they pass through it. Yes, try to think. It's correct. It's the optical lens. Number C, the deviation of the light path. Deviation means the change of the light path when it transfers from one medium to another, different in optical lens. Different in optical lens. What is the meaning of change the direction of the light between two media different in optical lens? Yes, it's the light refraction. It's the light refraction. Number D, it's the ratio between the sine of the angle of incidence in the first medium to the sine of angle of refraction in the second medium. This means sine phi over sine theta. What is sine phi over sine theta? Try to think. Sine phi over sine theta, it's equal n12. n12, this is called relative refractive index. n12 is called relative refractive index. Okay, the next question, it is the ratio between the speed of light in space and its speed in medium. Speed of light in space and the speed of light in medium. It's C over V. Of course, it's N, which is, try to think, N equal C over V. It's absolute refractive index. Absolute refractive index. The next question, absolute refractive index for the first medium times sine angle of incidence equal absolute refractive index for the second medium times sine angle of refraction. This means n1 sine phi equal n2 sine theta. This rule is called rule of what? n1 sine phi equal n2 sine theta. n1 sine phi equal n2 sine theta, it's Snell law. Snell law. The next question, it's the surface which all its points have the same phase, and this surface is perpendicular to the direction of wave propagation. It is the surface which all its points have the same phase, and this surface is perpendicular to the direction of wave propagation. You studied it from minutes. It's called wave front. It's wave front. The next question, it's a phenomena of superposition of light produced from two coherent sources and produces reinforcement of light in some region and weakness in other regions. You studied it. It's from the most important process which could happen to make the light a process, make a light a wave. This process make the light a wave. Yes, it's the light diffraction. It's the light diffraction. It's the interference that produces weakness in the intensity of light in some regions as a result of meeting of crest of one wave with trough of other wave. This weakness, this means this will give to us dark fringe. This is type of interference. It's distractive interference. Light sources, the next question. The light sources produce wave have the same frequency, amplitude, and waves. These sources are called, yes, we studied this. Try to think, what are these sources? These sources are coherent sources. The next question, the change of light path when it passes through a small aperture. This is the Airy experiment, and this is called the light, yes, it's the light diffraction. It's the change of the light path when it passes. It's the diffraction of the light. The last question here, it's a bright circular spot formed on the observation screen when monochromatic light wave diffract through a circular aperture. Yes, this is called Airy disk. Airy disk. Now we reach to the last, the end of this lesson of light, and I want to remind you with that, don't study physics when you are tired. Please pay more attention for solving problems. The most important point here is solving exercises as much as you can, due to it will help you to train your mental abilities. Please study physics daily. Don't give it a certain narrow period of time, because it will decrease your ability to deal with physics. Physics is a very excited subject. It will help you to think and think properly. It will change your personality. It will change your point of view about the environment and the life around you. Take care of yourself. Thank you for your time and have faith in physics. I wish for you to achieve all your dreams. Thank you for your time, and goodbye with a next discussion together about light in the next lesson in chapter 2. Till now, thank you and take care and goodbye.